But the trick here is, if you do this call based on the query that we issued earlier, you're going to be making one additional database call for every books. So if you have 20, you're making 20. If you have 2,000, you're making 2,000 more. So if you have 2,000 books, then you're making 2,000 plus 2 queries just on this page. Okay, so if 5,000 people hits this page at one go, then it will be 5,000 multiplied by 2,002 queries. And so if you do estimation like this, then the numbers should be very horrifying. And so if you want to go back to that example, we can tweak the query by doing this. So add this line, the one I mentioned earlier, select related. Right, then what Django will do at the back is they will combine the queries for you. So even if you do the same thing, the number of queries you are now making, including the count, is just total of 3. Okay, so this is a significant reduction. At scale, 3 multiplied by 5,000 is just 15,000. But 3 multiplied by 2,002, I don't know what that looks like. Right. I want to bring this up again because so Lara, she works at Etsy as a performance engineering manager. And what they do is they measure performance every day. So if you start doing for some of the more important views today, then over time you can expand to the whole site. And then when you have the whole site under your control, you know when things go wrong and what to optimize. But if you don't, you let everything roll and then you just go. When it happens, when the fire starts, then you panic and then you start doing all this, you're gonna hate yourself. Right? That's what I do. I hate myself every day. Okay? So part 3 is basically on what we call eyes on me, which is monitoring. Okay, so you want to do monitoring because things go wrong in the weirdest places that can ever happen. Maybe you have a very good piece of software that people say will never crash, and it will crash on you. Right, so everything that can go wrong will go wrong. Okay, so this is the part. I'll just give a true story lah. Okay, so this happened maybe not too long ago because it's still fresh on my mind. Okay, we have one database and we store a lot of things inside. Right, because databases use disk, so it's fine. Postgres is good. One day I checked what's the disk usage, we get an alarm because it's now approaching 80%. So if you hit this kind of limit, you should panic because you're dead. You have, and then if you look at the rate it's growing, it's like maybe growing 1 or 2% every week. So if based on our estimates, we'll die in about 1 month's time. So I just told everyone, all my engineers, I think we're going to die in 1 month's time. So what happens after that is we spend the next 1 week panicking and figuring out what steps to take. And then 2 weeks trying to save ourselves. And of course, we did lah, because otherwise I wouldn't be standing here. I'll be looking for a job somewhere. So this kind of thing tells you like, okay, no matter what. So what the main cause was because we have too many indexes created, but we didn't use them. So and then I had to optimize some of the indexes, like like the one I mentioned. If you can reduce the size of the index, then you will eat less disk space as well. Right. So for certain type of activities in our application, we will generate a lot of rows in the database. Right. So it's fine, but maybe if you're generating like millions of rows a day, and the size of the data, each row is big, you're gonna have a nice time. So you're gonna see very significant growth in your DB, your disk usage. Yeah, of course, the worst part is we didn't have proper monitoring. So we had no idea as to why it grew to 80% without anyone knowing. Because even though we had the numbers, no one was looking. And then we didn't tie it up to any proper alarm or alerting system. Right, so by the time it happened, it's too late. So since then, we invested a lot of time into monitoring. So we have all these beautiful graphs now. And I normally, again, I don't look at them unless something goes wrong. Then I can tell something went wrong. Otherwise, what we've done since then is we started measuring everything. So whenever something goes wrong or before something goes wrong, we can tell like, okay, maybe if you can see the lower curve, it looks pretty standard across the day. But if you were to see sudden drops or spikes, then that's when you know something is wrong. Right, so this is what my friend always say, if you don't want a surprise, then don't let surprise come to you. Avoid that. Right. So just to clarify, I never watched this show before. Okay. So it's just my friend's suggestion. Okay. Even though I think I'm from the era. Okay, so part 4 is about queues or celery queues if you guys have started use of it. And the main purpose of using, you want to use celery no matter what. Right? So it's because things that are slower, like sending email where you need to wait for SMTP server replies or even HTTP calls, take very long, and you don't want to block the user. So you can let this run in the background. Right, so you may have a lot of different types of tasks. So for us, maybe we have what we call like sending emails. This one maybe 500 milliseconds to a second, depending on how slow the server is. Push notifications faster, but if your user has multiple devices, then you have to make at least 2 calls. Right? For us, our users may use our app on Apple iOS and Android, and they will demand that the notification gets pushed to both devices at about the same time. So when you have such kind of requirements and users, and you're like, okay, and then maybe the slower ones process daily stats, because business side they need numbers to make certain decisions and see whether things are performing up to standard. Right? So you have all this kind of tasks running somewhere. And if you only have one celery queue and you don't configure anything, then this is the kind of scenario that happens. Everyone is queuing for this in the same queue, even though someone may just want to buy something small, they just want to take a spoon or what, but they still have to queue. Okay, so before I move on, has anyone tried this chicken rice before in Singapore? 天天海南鸡饭. Okay, okay. Then has anyone heard of it before? You guys, okay, so the general advice is, my friends say, you can try, it's not the best. There are better ones out there. When I come to Taiwan, I try something, that's what my friends say to me. Okay. So, the kind of like, the lesson here is use different queues for different types of salary tasks. Salary allows you to configure that. So, monitoring everything, right? So we monitor our queues as well, how many tasks is living in each queue. So we have what we call low priority queues and high priority queues. So low priority ones are stuff that I don't care, right? It can be slower. And there are high priority ones where it must get done now, as soon as possible. So by monitoring, I can tell like push notifications, it should be low or none because they all get sent out immediately. Right? For salary, where we do a lot of generic things, it's fine, I don't care. So when you do all these kind of async tasks at scale, you want to separate all your tasks so that they don't jam up each other. Right? So as much as possible, try to segment your queues into 2 types. One is high priority, one is low priority. So this is the kind of guideline. For us, so in our app, we have push notifications. So we use high priority queues, and we have an army of workers doing nothing but sending out push notifications, because otherwise our users will be unhappy. Yep. And maybe for certain companies, you want to do what we call like weekly emails, right? So whether this is low or high priority depends on your business requirements. So if their expectation is all the emails must be sent out between 1 to 1:30 p.m. Right? So if you have certain requirements like this, then yes, you need a dedicated set. If it's just as long as it gets sent out on Saturday or things like that, then you can just use a low priority one. Okay, so salary is really, really powerful. We are still learning new stuff that we can do with it every day. Every time we need to do something magical, and then we realize, wow, someone already did this magic somewhere. Right? So, let's say, if you have logged in, every time someone signs up or stuff like that, you want to send an email, and a lot of people sign up, and you have a lot of other asynchronous tasks just in one queue, you're going to have this jam scenario. Everyone's queuing, and your workers cannot differentiate what is important and what's not. So you have to create queues to tell them, this is more important, this is not. Right? Okay, and then just nice, because time is almost up. The last part I'll talk about a whole new world. So the lesson here should be that you can't do everything to scale from just Django alone. Right? You can trick yourself, you can lie to yourself that Django can handle everything for you, but you still have to go beyond Django. Right? So you need to look at servers, you need to look at ops, you need to look at your databases, you need to look at your whole infrastructure. That's the kind of lesson we learn. So as much as we try to tweak Django, things break down in the weirdest places. Maybe we use RabbitMQ as a broker task for our salary. RabbitMQ has some really, really weird behavior, I don't know how to describe. Like you will be running, but you reject connections, and I don't know why. There's nothing in the logs, and no one has encountered this before. So, and then the cure is restart the RabbitMQ server, then it's back to normal. Yeah, then no one knows why. I think that happened to me last week. Yeah. So, going forward, you want to do more things like monitoring your database activity. So if you're using Postgres, then you should check out their awesome documentation. So you know like what things are going on in your database. How do you monitor how many transactions, how many requests per minute? right? All this we are monitoring, we are tracking them, so we know whether something goes down or wrong. When you have more and more servers, there's a higher tendency for things to go missing. Or when you want to add servers on demand, you want them to be, you want them to join cluster without any sort of downtime or manual intervention. So you can use service discovery, or you can use Amazon kind of infrastructure. So Carousell is one of the things we are experimenting now. So they let us do things like if I spin up a new application server, it joins the cluster immediately. Or databases, or maybe we spin up a new service and call it by maybe a domain name, internal private domain name, as opposed to an IP address. Right? Maybe because this server dies, the domain name can do round robin. So they know that, okay, I'll switch the remaining two. Okay, so if you look at stacks like Netflix, where they deal with a lot of traffic, you will notice that their application server, which is stuff like Django, is only one small part of their whole infrastructure. And this is what it needs for them to scale. Right? So if you look at the whole thing, you will see like they use a lot of databases, they use a lot of tools, and they have things like continuous integration, service management, log management. All this will come into play when you hit certain scale, because you don't want every downtime to be like a murder mystery. You don't know who did it, and you go every server to find out. And so that's going to be very time consuming, and when your app or server is down, and you're sitting in the office and everyone's waiting for you because no one else can do any work, then the pressure is on. So Discuss is another company. They use Django to build their command system. So maybe you've been to some blogs and then they use Discuss as a commenting system. So they also build on Django, and they scaled it for a very, very long time with this type of performance, with this type of latency. Of course, after that they asked themselves, why am I doing this? So they changed and wrote in Go instead, and they got a huge performance boost. That's also one possible way to solve your problem. If you have enough people, you can rewrite in another different language for performance. But don't do it if you're the only person. So they have a whole team, so they can do it. If let's say someone else, just between my current company side, someone wants to rewrite my whole backend in Go, I will have to talk to that person privately. Okay, so in summary of all that I mentioned, the first part, stuff you should look on, focus on your ORM in your database. Okay, if you don't measure, you can't predict the kind of performance you need to deal with when things really go rough on you. Okay, start monitoring everything. If not, everything becomes like a murder mystery, and you don't want that to happen when everyone in the office is waiting for you. Okay, if you're using celery a lot, then plan for it. Don't let it become one of the major factors that's blocking you from doing all the tasks. Okay, and then last point is the one I mentioned, so go beyond Django. Right? Don't just focus on Django. If you hate touching databases and you want to work in a start out with a lot of traffic, you are expected to be able to deal with the database by yourself. Right? So this kind of things can't be taught. You have to learn and maybe go through a few fires yourself before you can master the whole thing. Okay, so that's all I have today. So thanks for inviting me here, Andy, Michelle. It's my first talk in Taiwan, and I'm happy to do it in English. Maybe the next one I can do it in Chinese. Okay, so I think I have one in Chinese next one. Okay. Okay, so I don't know if we have time to do Q&A. If not, it's fine. We can do it later while we're having dinner and stuff like that. And if you don't want to talk to me because you have no confidence in my Chinese skills, then you can write to me online. Okay, so thank you. Thanks, everyone.
因为时间的关系，那个。